Hi all, in this lab, let us understand how to create custom schemas and generate some code bindings for that schema. And using that code binding code, let us write one target to process the events. Okay, so schema is one of the another very important concept within the event bridge. Okay, so in this demo, let's understand how the schemas are generated, how to process them, and how to generate the code binding. And we will also, have a lambda function created based upon this code binding, and this will also write an event to a DynamoDB database and also event back to the event bridge. So this is an end-to-end flow. Let's get started. Okay. Now in Amazon Event Bridge, let us say first we have a default event bus. Okay, the name of the default event bus is default, and then we also create a custom event bus by name orders. Okay, so this is our setup. Then we will be having few resources created along with the event buses. Okay, so on the event sources, let us create a custom event and send that event to the event bus of name orders by using AWS CLI. Okay, so when the event bus by name orders is created, we also enable the schema discovery feature. Okay, we enable a schema for this bus. So that means anytime a event is sent to this event bus, a schema is automatically generated and it will be stored into the schema registry. Okay, so it is completely automated. We do not have to update the schema registry. It is automatically generated. Now, developers can make some calls to the schema registry to develop some to code bindings. Basically, they can generate the code bindings, which basically have a template code to process the events based upon the structure that the event schema provides. And the code bindings are available for different languages. It could be Python, Java, things like that. So in this example, we are going to create it for Python. Okay. So let us see what targets we're talking about here. Okay, so we have one CloudWatch logs target, which has a resource policy to allow Amazon Event Bridge to send logs to. Okay, then we also have one more target, which is Dynamo Lambda function, which will write to the DynamoDB database. Okay, and this Lambda function also will have a resource policy to allow Event Bridge to send events to. Okay, now then we have a rule which will trigger both targets, the CloudWatch log and the Lambda for the same event if it's matched. Okay. Now, end to end, what we're going to look at is basically when a custom event is sent, a schema is generated and the schema will be stored in the schema registry. Developers can do the schema discovery in the schema registry for various schemas which are generated. There are schemas for the AWS events and there are schemas for the custom events, also schemas for the SaaS applications as well. Okay. Now in this case, the developers can use the various CLI options to generate the code binding, or they can use the command line option or the console options also. Now, in this case, we will be using a CLI called SAM, Serverless Application Model CLI, to generate the code binding. So, using that code that is generated from the code binding, which is based on Python, we will be creating a Lambda function. The Lambda function will have some roles assigned to the Lambda as the execution role to allow it to write to the DynamoDB database. Okay, so we'll create the DynamoDB database as well. So in this source code, let us understand how to implement the Lab6, which is an event bridge with event schema. Okay, so let us see how we have to use a Terraform module to implement this architecture. If I go to the eventbridge.tf, so this is where I'm creating a custom event bus by name orders. Okay, and create underscore bus is true, and I'm also enabling the create underscore schemas underscore discoverer. This is important. This is where the search discovery, the discovery of the schemas will be enabled. Okay. Now I have one rule, and the rule says catch all the events with source com.aws.orders. Okay, and the rule state is enabled. Now I have two targets. One target is going for the CloudWatch log group. The second target is going for the Lambda. Okay, so two targets for the same event. And for Lambda, I'm just enabling some more policies. Attach Lambda policy is true, and also the target Lambda ARN, which we need to specify here. So if I come down, you will see the CloudWatch log group creation and also the corresponding IAM permissions required to put logs into the log group. Okay, and the principal is events.amazonaws.com, and this is a resource, and this is a log group name, and these are the events, APIs. And this is the CloudWatch resource policy that we have to create. Okay, it's not the identity based policy, but it's a resource based policy that we are creating to allow the EventBridge service to write logs into the CloudWatch log group. Now let us go to the Lambda. So in the Lambda, we are creating one function, which is basically the event processor function based on Python. And the built-in Docker is equal to true, the source path is on. So basically, if you look at the source code is generated by the code binding schema. Okay, so we will see that in a minute how to generate that. So this is a requirement.txt file. So if I go to the hello world function here, so go to the Lambda code, and inside that we have hello underscore world underscore function, then hello underscore world. So this is where my app.py file. So this is my primary file. Okay, and lambda underscore handler is the entry point. It's a requirement file, and this was generated by the schema code binding that we will see in a minute. This is a schema. Okay, so if you look at the event.py, so you have some code to handle the AWS event, and there is a marshaller.py. So marshal unmarshalling the events is done, and this is the code binding for the Python. Similarly for other languages also that we can create the code binding and leverage in our business application. Okay, now this is a Lambda source code path, and timeout I'm specifying 600 seconds, and some policies I'm providing to Lambda. You can decide which policies you wanted to provide, and I'm also attaching one more policy. Okay, and allow trigger. So this is a resource level policy. I want EventBridge to send events to Lambda, invoke Lambda, right? So this is my policy on the resource. Okay, so I'm just saying that this particular rule, EventBridge rule from this event bus can send events to this Lambda. Okay, and so this is the event processor IAM permissions. So since I need to write an entry into the DynamoDB database, I'm also providing the API permissions to various operations for the DynamoDB. And this is my DynamoDB table. Okay. And this Lambda function also will write another event back to the CloudWatch, EventBridge event bus. And so event bus that we have created earlier is the one which is the target here, resources here. Okay, so it will also, once it process and the event will send an updated event back to the event bus. So let us look at the DynamoDB database. In the DynamoDB, it's a simple one. I'm using the order details as the name of the table. Order ID is a hash key, which is of type string, and the pay per request is a business billing model basically. Okay, so now let us go to the backend.tf and check, this is using a specific folder inside the S3. Now let me do Terraform in it, and Terraform plan. Okay, so it's going to create 24 resources, and Terraform apply with auto approve. Let us give it some time. It's going to create so many resources. The entire infrastructure for the end-to-end architecture of this Lab6 is going to be created now in one go. So it is completed. You see there are 24 resources added, 0 change, 0 destroyed. Now let's go to the AWS console and see how the resources are created. Okay, so let me first go to the EventBridge service. Within that event bus, there is one custom event bus that we have created, and within that there is one rule. Okay, see there are two rules here. One is the standard, that is the one which we have created. There is one more managed rule. Okay, this is for the schema. Okay, because every time an event is sent, this managed rule will be also created. I mean, managed rule also will work to create the schema. So the rule which we create is using this as the source pattern. Any event with com.aws orders will be processed and merged. Okay, so there are two targets. One is the CloudWatch log group, second one is the Lambda. Okay, and let's go back to the rules and check the other one. So if you see the other rules, let me select the orders one. So there is a managed rule. Okay, so it is selecting this particular event pattern, and the target will be the schema. Okay, so it's creating a new schema that we will see. Okay, so we will first generate a sample event and check how this work. So this is our sample JSON file which contains the event data. So let us go here. Basically we have test events folder. This is the file which contains the source and the order details and the event bus name, so and so. So let me trigger this. The file is already created. Now I will send one test event. Okay, so this is the event ID. Now we will just copy this and check whether the event is received by the respective rules. Now let us go back to the console and let's first look at our basic rules. Okay, so the first one is the CloudWatch logs. Okay, so in the CloudWatch log group we see one log stream, and we can just search for the event ID, and it's a um, same ID that we saw. Okay, now CloudWatch log group is triggered. Now let's look at the Lambda function also, whether it's able to process the event or not. So this is the event processor Lambda function. So this is EventBridge is a source. This is the configuration. This is the code. Okay. So out of all of this code, some of the code is generated already using the code binding, and this we have updated to talk to the DynamoDB. Now let us look at the configuration first. This is the execution role, and if you look at the execution role, the permission that it requires to talk to DynamoDB and other services are there. So these are the managed policies, and this is the custom policy that we have created. And there is a resource level policy also that we have provided, because we need to allow EventBridge to send to this particular Lambda. Okay, so let us go to the logs. Okay, and see whether the logs were available for the event that we have sent. Okay, so if I go to the log stream, this is the Lambda function logs. So you see there are a lot of logs available. Let me search for this. So this is the event that we received. Okay, U West 415. Okay, now we're also sending an event back to the event bridge. Okay, so now let's first go to the DynamoDB and verify that Lambda is able to update a record there. So I will go to DynamoDB. So in the DynamoDB tables, we have one table which we have created. Let us explore the items in the table. So this is the one we saw. Okay. So this is the order ID that it generated, and it has written this event. Okay. So whatever you have sent, the Lambda is written to the DynamoDB. So this is how we can um, you know test end to end, right? We have sent an event through AWS CLI, the EventBridge rule is triggered, and CloudWatch and the Lambda receive that event. Lambda in turn will write a entry into the DynamoDB, and it also sends an event back to the CloudWatch event. That also we can see. So if you look at the orders event bus, you see there are two events. We have sent only one event, okay? The one event is the one which you have sent through CLI, but one more event was sent by the Lambda. So that's why you see two events, okay? Now out of the two events, if you look at the rules, right? So the rules that got matched. So if you look at the monitoring, you can see that the invocation um, the matched event is only one, because only one event it has matched, because we don't have any rule for the second event which Lambda generated, right? The triggered rule is also one. Okay. So but again invocation is two, because it may be sending the invocation the other for other event. Okay. So now let us go back to the schema. Okay, that's exactly what we wanted to show here, right? So if I go to the schema, and if I go to see, this is all schema, and this is the AWS event schema. These are the default AWS events, and the schema generated, and the discovered schema, and this is a custom schema. Okay. Now let's go to the discovered schema, and here you see two events, right? This is the event, this is a schema that we sent. This is the event. This is another one which is the one which is sent by the Lambda. Okay. So for every event which gets sent to this particular event bus, there will be a schema generated. The schema will be looking like this. Okay. So this is useful for the developers to understand what structure the event looks like and how to write the code and things like that, right? And to do that, we can download the code bindings also in this one. Okay. So using this download the code bindings. For this, we can download the code, reference code to implement in various languages. Okay. And that exactly that. So if I go to my um, code base, and if I see there is a SAM, I just used serverless application model CLI, and I generated this code. Okay. And so if you look at the events, this is the event.json, and this hello world function that we saw earlier, and some test, and this is the template.yaml file also. This is the YAML file to define the infrastructure. So all of this is already generated. So from this I took this hello world function, and I put that into the lambda hyphen code, and I updated hello world with the app.py updated with some more code. Okay, so this code talks about using the DynamoDB table to write an entry and also send an event back to the CloudWatch event. Okay, so this is how we can test the end-to-end flow by generating the schemas for the event bus, and generating the code bindings from that schema, and use that code binding in our code, and add our own business logic, so that the developers, new teams can discover the schemas, and develop the application business logic easily using this schemas feature. Okay.